Mhm. Is it getting super hot for you guys out there?
It's been pretty overcast right now, but I'm like near the coast, but immediately inland, it's definitely heating up. How
Yeah,
about you?
it's a high of 90 today.
Oh, wow.
I went out for a very brief stroll, maybe 5 minutes, and I came back and it was just like, ugh,
Yeah, it's
too
on.
much.
Summer is starting.
It really is. But oh well.
Yeah.
I have a backyard where I do like to do the gardening, and
Nice.
we just moved like last August, and the plot is just all lawn, and I don't like all lawn by any means. And so I'm trying not to be frantic about putting plants all over, but and also not gardening directly in the ground
Right.
because I think
Right.
that thing got treated a
Yeah.
lot. But yeah, so that's been a fun focus this year. But it's
Good.
so hot so quickly. I don't know.
I hear ya.
The plants are maybe not going to hang on. Yeah,
Fingers crossed.
yeah, we'll eat what we eat.
Should we get going?
Yeah, sounds good.
Awesome. Welcome everyone to our second Lunch and Learn. I'm here, my name is Mo Wise, and I'm here with Jessica, who is a researcher at the Illinois State Geological Survey with the PRI Research Institute. And she's going to be talking about monitoring roadways and aquatic resources to answer regulatory questions. And if you have any questions during her talk, please include them in the Q&A section. There's kind of a talking section and then a Q&A section. So hopefully you can get your questions in the Q&A section and Jessica will answer them at the end. Yeah, so hold on to your questions or add them as we go and we will touch them at the end. And I will give you the go. Jessica, go for it.
Well, thank you, Mo, for inviting me to speak today. It's been a good moment of reflection for me. Today, I'd like to share a little bit about one of my section's current monitoring projects that highlights some of the unique qualities of where I work. Where you work defines what you get to do. My hope is that by the end of this presentation, everyone will have a basic understanding of the context and value of this project, the I-90 Chloride Migration Project, which is part of our tollway program. And hopefully everyone will walk away with an understanding of how the Wetlands Geology section operates and complements the mission of the PRI Research Institute at the University of Illinois in Urbana-Champaign. To try and get through everything in good time, I'm aiming to break this up into some main topics. You can see them there. All of the icons will be on the right so that you can track where we are in this presentation as we go. Starting off, where do I work? I can get really intimidated by that question sometimes because there are several different tiers, and I don't think this happens in many locations beyond where I am. I'm at the University of Illinois in Urbana-Champaign. And at the university, we have the PRI Research Institute, which is with the university, but it houses these 5 surveys for Illinois that all have their own operations and pursuits. And within the Illinois State Geological Survey, you will find the Wetlands Geology section where I work. We're a fun bunch of folks, and I'd say I just want to recognize them right ahead of time because they're fun to work with, and everyone whistles while we work. And we all work toward the the missions of our section, and it coincides with the mission of the PRI Research Institute. The PRI conducts transformative science that benefits the people, economy, and environment of Illinois, the nation, and the world. And there are 4 main impacts that they outline on their website. A lot of it revolves around sharing information and providing useful information to the public, and potentially having these resources of information for interdisciplinary science. The information is used in various ways depending on which survey or section within a survey is operating with that information. Just last week, I looked up the research news, and we've got reports on how right now it's warmer and drier in Illinois than usual. You have surveys revealing, looking at geology data and overlapping data sets that, when combined, we can report on the impact to communities throughout the state, and potentially those have impact then to the nation and the world, because geology doesn't stop at one state and go into change completely into the next. This is all one big depositional environment. At the Wetlands Geology section, we started our work in 1992 with the Department of Transportation, and we've continued on, and our section's focus is to monitor and provide findings to sponsors who have asked us mitigation and remediation questions that are commonly driven by regulation at both the federal and the state level. And here's a general list of what the regulations that drive the work we do with the Illinois Department of Transportation, the Illinois Department of Natural Resources, and the one legislative authority is the Illinois State Toll Highway Authority. We just call this the Tollway Program. Our findings can relate to areas that are needing protection, like nature preserves, but often we also are monitoring areas that were installed to provide remediation and protection for the environment. Here you can see the United States and where Illinois falls within the US and the Mississippi River drainage basin. And then when we move to the inset, you can see the LIDAR representation of Illinois' topography or land surface. You can see we have highest elevations in the north, lowest in the south, and that's just general. The yellow dots represent all the various locations that our section has conducted work. Under the Tollway program, our focus is on assessing the effectiveness of BMPs, primarily by collecting water quality before and after construction of these roadway and mitigation measures. A BMP can take many forms. Here's a photo of what is a bioswale, which effectively is a linear treatment wetland. Here's the basic before shot in the background, and then over here you can see the after. And up on this hill or higher elevation area is I-94. And here's a lovely little drainage feature that dumps a lot of the runoff into this ditch, where we have plants and materials that work to remove the waste, the runoff, the things that we don't want going into the rest of the environment. And this monitoring is directly related to the regulations under the Tollway program. So, I mean, there's an overlap here between why is Tollway, why are there regulations? Regulations are there to protect our environment, which also protects us. At the same time, we have roadways in northern Illinois and across Illinois. Wherever we get snow, we can have ice on the roads. The roads are there to help us get where we need to go, including first responders and many others. But when you have snow and ice on the roads, how are you going to get where you need to go safely? So the magic element is, or the magic thing we put on the roads is salt, which prevents ice from forming on the roads, provides us that safety. But safe roads during snowy winters can cause chloride pollution with abundant application of road salt. And when chloride dissolves and it runs off with the runoff from the roadways, it's entering the environment, which can impact the environment where we like to go to perform various forms of recreation, including hunting and fishing at the same time, if you can. These are areas where we have natural processes taking place. We have plants and animals that are relying on these environments. And, you know, just in general, we are consuming fresh water, not just fresh groundwater, but fresh water at large quantities. To give you an idea of how to visualize this, in 2015, the US was estimated to have consumed about fresh surface water, about 32.5 billion cubic meters in just that year alone, which if we look at Wrigley Field here, you know, it's a nice big field and we have the bleachers, the top bleachers. This quantity would fill Wrigley Field to the top of the bleachers over 850,000 times. And that's 1 year's consumption of only fresh surface water. So we all rely on water. And the impact of chloride, it's surprising, you know, in the ocean. So here's this bar chart here to try and drive a few concepts home. You've got your ocean water, which is naturally salty, which is estimated to be at about 18,000 milligrams per liter of chloride. This is the same if you had a jug of water, and you dumped 20 teaspoons of salt in there. That's the same concentration. On the other end, you have an estimate of unaffected groundwater, the threshold for unaffected groundwater, which was an estimate by a group of folks at PRI in 2006, Pano et al. And they estimated a threshold of 15 milligrams per liter of chloride. If you look at that same jug of water, you're putting 17 1,000ths of a teaspoon of salt into that gallon jug of water. So there's quite a broad spread in nature, but then in terms of what our impact is, there are several standards. The potable and general resource groundwater standard by the Illinois EPA is 200 milligrams per liter. Fresh surface water, the general use standard, is set to be at 500 milligrams per liter of chloride. But then you might notice this blue line in here. There has been work by the US EPA, which assessed chronic chloride toxicity of freshwater to be at 230 milligrams per liter. So in terms of Mother Nature, our impact doesn't look that bad, potentially. What we're aiming for is pretty low, but even within these standards, you start to impact the environment pretty quickly with less than half a teaspoon of salt in a gallon of water. Tollway is aware of this, and they have their own questions because they're trying to maintain these safe roads. So they want to make sure their BMPs are working as best as they can. And they asked us this question, which led to the this project of how does chloride that's applied to roadways as road salt, how does it migrate through coarse materials away from the road? Luckily, so there was no specific location to go monitor. We basically were allowed to consider the geology of Illinois, look for an area with coarse materials, and there was one right up here, an area with coarse materials that is bisected by the Illinois Tollway, I-90, and we happened to find property here that was forest preserve property adjacent to the Kishwaukee River, and the managers from both districts took us around the area and expressed their own interest in knowing what the impact of the roadway was to these forest preserves. So with that, we signed some permits, we made it official, and we started the study. In order to get to the point of actually collecting data, we had to take a few other steps up front. It included just looking at the area, finding our inputs, our outputs, where's the water coming in, where's the water leaving the system in this particular monitoring area, what's the high ground, what's the low ground, where is water going to flow. So, here's I-90, and here's one of the roadway ditches that runs right along it, and I'll show you a map in a second. But so once we identified these locations, we marked out where we were hoping to install monitoring points, because you can't just go out and dig in the ground, right? We needed to call Julie, call before you dig, always. And that includes scientific research purposes as well. So we got Julie's approval. Everyone came out and sprayed and marked as needed. We had to think about how we were going to be installing our wells. These were wells that were going to be 10 to 15 feet below ground surface. And we were going to need a rig. How big is the rig? How do we get to the south side of the site? Because there's this little narrow trail, and then we have to go under a bridge. So we had to really, really check what challenges we could eliminate up front for permitting a successful installation of the site. Up front, before we even had wells installed, we also went ahead and got some installations in the ground for monitoring surface water. We made sure to mark access points for those, for the folks who were coming out to collect the data in the meantime. And then we got to installing some monitoring wells, which was a multi-step process, because again, this study is focused quite heavily on what the materials are. So here you see our power probe. We call it the geoprobe, and it came out and went to all the locations that had been approved by Julie already, and we collected core samples of material down to the same depths that we were installing the wells. We had up front very limited recovery at times because it was very coarse material below the ground surface. After collecting the cores, we installed the wells. Here's again the same rig did the next step for us, and we installed 2-inch PVC down to between 10 to 15 feet below ground surface. Got some nice aluminum casing on there to protect the wells, because these are forest preserves and we want to make everything look nice and contained. It is nice and contained, and we want to reassure the public that's walking through here as well that things are contained. Here's just a picture I had to throw in because I enjoyed this moment sitting on top of a hill looking out over the Oxbow Lake. while the drill team installed the well. That wasn't the last step before we could start monitoring. You know, when you install a well, your screen gets pretty gunked up with materials, and what's coming into the well needs to be representative of as representative as possible of what's in the aquifer itself. So we had to develop the wells. This was a multi-step process of bailing. Here we are still on the hill, bailing as much water out of there, agitate, and then remove, and clean that screen out. And we found, because of the materials that were coming through, that we had to bail first. And we bailed until we saw clear waters, and continued to check parameters and water levels throughout to see how the water levels were responding. Once the water was clear, we went on to pumping. This was with a geosub across all of our locations. And really, during this process, we saw a very stable water level across the site. And so then the site was installed, and here's a nice map view of it with some LiDAR, as well as you can see the National Wetlands Inventory. The most recent collection or data set is mapped here. But you can, it's really kind of hard to see what's actually happening on the monitoring site in terms of elevations. You can see, the one thing you can tell is that it's a very low elevation, and we're right by the Kishwaukee River, so that makes a lot of sense. Bear with me. I'm adding a clip, an interior clip of this very low area, so that you can better see that there's actually a change in elevation. It's slight, but you know, we're up here in the high ground in the northeast, around where this pond is, and there's our lovely Oxbow Lake with a nice high hill. This is that well 4 sitting on top of the hill. And the high ground transitions as we move to the southwest. We move into low elevations. So everything's installed, everything's developed, it's all ready to go. Now we can start collecting some data. So we installed aquatrolls in all of the wells and in all of the surface water locations to collect water level and specific conductivity, so that we could get a continuous read of that. We also installed dedicated hosing in the wells to facilitate water quality sampling at the site. And you know, if this was just a straight up study, that would be it. But there are consistent resources, and there have been some really interesting collaborations at this site because, again, we're with the PRI. The resources are tremendously helpful. The Illinois State Water Survey has the Health and Environmental Applications Lab, where we can take our collected field samples and they will analyze them for us. Again, we couldn't have set up the site or collected as all of that core material as successfully as we did without the ISGS drill team. And moving into the study itself, you know, we're trying to do a full characterization of the materials in congruence with the migration of chloride through that study area. So the hydrogeology and geophysics section at the ISGS offers various process, you know, you can hire them for various analyses, and that included the electrical resistivity tomography data, which this is a few shots of that. There's the big data collector, and we collected transects of ERT across the site in line with the wells more often than not. There was also a collection of GPR. Some of those were overlapping with the ERT, which in itself has created another interesting evaluation or study for that section to compare how the transects are useful and contrast with one another. This information for us is just helpful to confirm what the regional mapping says, and also a way it's also a useful tool to potentially identify lateral features that may impact the flow below ground surface. The ERT is really focused on giving us a range of the grain size. It gives us that in kind of detail. There are a few requirements to get a good readout of it, and then we also have from our core samples that we collected, at every foot we collected subsamples, and we were able to go back to the sediment materials lab and analyze for particle size analysis. And another thing, data set that was really complementary to the ERT is cone penetrometer testing and hydraulic profiling tool data. That is also called CPT HPT, which is a little shorter. Here's a general view of the setup to collect this data. This is again the geoprobe, but this is the thing that's put into the ground to collect a full column of data. This is the raw data readout at one of our wells, well 6, I believe, and the tip. The bottom part helps with characterizing the materials in terms of assessing how much resistance there is. And then you also have other sensors on here to assess the permeability and the conductance of basically assess the permeability of the materials as you go down one column. This data was brought to us because there is a study going on in Boone County by the ISGS hydrogeology and geophysics section, where they're collecting this kind of data all across the county. And so for them, we were providing another helpful data point. So that was a really fantastic opportunity that we took. Also, because we're with the university, we have these incentives and programs to focus on educating, and the ISGS Paul Edwin Potter internship program allowed us to bring some undergraduate students to the site and teach them about applied geosciences and learn about all the ways that we were collecting field data at the site and what to do with that when you come back to the office. So really just trying to give them that real world experience. But then in terms of, so that's all the collaboration. Those are all these different collaborations and resources that exist because, again, we're at the PRI. In terms of what we're seeing at the site, though, in terms of the question about the coarse materials and where is chloride going, first up, the big thing, resounding answer is we've got coarse materials. We had confirmation of coarse materials. Here's north of I-90 by the river, we've got this core. And you can see even up here, we've got sand, lots of sand, and then we get lots of gravel into cobble size, really. And you might see ranges of how much organic matter there is across the site, but very consistently, we are getting to coarse materials all across the site. That was south of I-90 by the river. And then here's over on the east side of the site, north of the roadway. So then we've got coarse materials, but what about the water levels? What about land surface? We're in a floodplain. You already saw this was very little detail here because we're at such low elevate, like there's not a large range of elevation change. So what we're seeing is really that there's an opportunity for flow in different directions because it's such a permeable material, but our gradients are pretty small. So it's not totally clear that there's much flow going on. Here's a box plot. Here are box plots of the site both north and south of I-90. Here, this transect here is following this line. And this is a year's worth of water level elevation data with the green lines noting the land surface. And you can see that I think one of on the north end, the most important point here is that in terms of land surface, the roadside ditch right here is the lowest across these monitoring points. It's the lowest elevation. The water level elevation is pretty much the same as at the well just north of it. The river is by far is a likely destination. It's the lowest land surface elevation. There's the greatest chances that everything's flowing to the river. If it's not flowing to the river, this ditch, because it's such a low land surface relative to the rest of the site, you can see it's quite likely receiving the groundwater from the site. So this ditch receives that water. It's also receiving the runoff from the tollway, and we've seen it constantly flowing year round so far. It doesn't flow to the east, it flows to the west, to the river, which would suggest preliminarily that it's carrying the chloride away from the north end of the site, but it's also carrying the chloride to the river as we continue to, if there is a lot of chloride. On the south end, we've got this roadside ditch that's at a higher elevation, and the water level elevations tend to be very much higher than the rest of the south monitoring points on the south of the site. Here's transect 1, 2, 3, 1, 2, 3. Our lowest elevation well to the Kishwaukee River. Again, the final destination seems to be the river. But there's a question of the connectivity of this roadside ditch to the site. It definitely does not flow to the river. In general, the roadway is seemingly working as a no-flow boundary. What the chloride has told us so far, or the sampled chloride, is that surface water ranges anywhere from 11.4 milligrams per liter up to 285.3 milligrams per liter. So we're not exceeding, so as far as we can tell from these a year's worth of sampling, we're not exceeding the general use standard of 500 milligrams per liter. Sometimes we're getting rather low, below the unaffected threshold, but we're definitely seeing some impact. And the question is it an impact from runoff? Is it an impact from aerial deposition? There are a few different ways that chloride can actually travel from the roadway. What is interesting to me here is you can see the yellow lines are plotting the time series of chloride within the roadside ditches, while the blue lines are plotting chloride within the river. And this green line is chloride in the pond on site. And so you can already see that there's there's more similarity here with the river on site than there is with the roadway. So as we move forward, there are a few things coming up. We need to calibrate that CPT, HPT data by running some slug bale tests in the wells, seeing how the water levels respond. We were excited to hear that the ISGS hydrogeology and geophysics section also has the ability to map salt plumes. So we could start to monitor the site, look for the wet time of the year, and hopefully get out there and physically map a plume of salt relative to the tollway. We also would like to have a better understanding of what these samples of chloride, measured chloride, mean more continuously. And we can estimate what chloride is doing more continuously by using our specific conductivity data in hand with our field samples to model or create a linear regression that gives us a general estimate and helps us view an estimate of chloride throughout a full monitoring year. And ultimately, as we develop big findings, we will be reaching out to the Natural History Survey who's involved with the Urban Biotic Assessment Program, which surveys freshwater mollusks in the rivers and streams within the tollway corridor. And they just happen to be doing one of their surveys under the bridge in the Kishwaukee River at I-90. So this is going to be, there's a lot coming up yet for this project, and we are really only not even through 2 years of monitoring. So with that, I would like to thank our sponsor for pursuing improvement and working to meet regulations. I'd like to thank all of the folks who are at PRI who have been involved in this project in one way or another. And I'd like to take a moment to say thank you to everyone here who has come to listen. I do acknowledge some broad strokes, but I invite anyone who is interested for more technical discussion to please consider emailing me if you'd like. We will also be, me and some co-authors will be presenting some of this data at the upcoming SWS annual meeting. We have a poster, Chloride Migration Off Roadways into Adjacent Floodplain Wetlands. So find us there. And just also as a side note, if you are interested, or if you know someone who's interested in this kind of work that seems to go between all over the place, it's lots of great opportunities. We are looking for more folks to join us, and we welcome your applications. So with that, if you have any questions for me, I'm ready to answer. Hope it was fun.
Thank you, Jessica. That was awesome.
Cool.
Yeah.
Turn off my laser pointer.
Let's see if any questions roll in.
I'm not seeing any, and I mean, that's fine.
We could wait a couple minutes in case anyone may have some.
For sure.
And just as an announcement, we do have our third Lunch and Learn. It is going to be next month on July 12th, and we're going to have Angela Burrows speaking about restoration work. So also feel free to join for that.
Thank you. I was on time. I'm impressed.
Yeah, you nailed it. You nailed it.
I'm
Well, I
excited
guess,
to, oh, go ahead.
oh, I'm sorry, you can go ahead.
Oh, I was just gonna start conversing with you. I'm excited to see you at SWS at the Women in Wetlands gathering.
Yes, no, that'll be awesome. Oh, that was sweet. Yeah, I think that'll be nice. That's how I got involved this year, was from a previous networking event. So hopefully it's helpful for other folks too.
Fantastic. Oh, I'm seeing some chats.
Yeah.
Oh, thanks. Thanks, Edward. Thanks, Stephanie. I appreciate it.
Awesome. Well, what do you think? Do you want to wait for some more questions, or should people email you? What are your thoughts?
Let's see if we're at 40 minutes. I mean, I think it's helpful to mention this recording will be up, and
Yeah,
so
that's
my email will be right there available to folks who would like to reach out to me, and if you can't make it to the meeting. So maybe, I mean, that seems like enough, right?
Yeah, that's perfect. Thank you guys for coming. And please feel free to email me also, wise@irwd.com. And my email is on the website as well, if you are interested in participating as a speaker in the future. So thank you. Thank you, everyone.
Thank you. Yeah.